This is Secondary 1 Math Lesson number 11-3, Part 1. This is reviewing some things that you've learned before as far as combining like terms and multiplying. We'll also be using our rules for exponents, what we have just been reviewing. So on the warm-up, number 1, it says to simplify, and that's just another way to say do whatever it says to do. So 3x times 4x squared, I'm going to do 3 times the 4. And x to the first times x to the second, which is x to the third power. Number 2, I'm going to do 12 times negative 3, which is negative 36. Notice that the negative did not move anything in that number. Then I'm going to have a times a, that's a to the second power, times b to the second power. Okay, the next one, number 3. I've got parentheses, and that just means I'm going to be multiplying. So I'm going to do negative 2 times 3 is negative 6. M to the second times m to the third is m to the fifth. Okay, number 4. If I have 2a squares and I add it to 3a squares, I have 5a squares. When you are adding or subtracting, you have to have like terms. That's not true when you multiply or divide. You see up here we multiplied and divided. We did not need to have like terms there. But when we add and subtract, we have to have like terms. And so that's something that we've talked about a lot this year. You've talked about it in years prior to this. Okay, number 5. Where are my like terms? I've got x squared and x squared. Those are like terms. So I have negative 3 minus 2. If I have negative 3 and I lose 2 more, I've got negative 5 x squares. I do not add the exponents. I do not say x squared and x squared is x to the fourth, because it's like if you have a cookie and a cookie, you have 2 cookies, not cookies squared. So remember that this is adding or subtracting, and that is different than multiplying or dividing. Okay, and then number 6, this is using our distributive property, which we'll be using a lot today. So negative 2 times x and negative 2 times negative 4. Okay, next, number 7, again the distributive property. So 3x times x squared. So we're multiplying, we don't need like terms. I'm going to have 3x to the third power. Then I'll say 3x times negative 1. So that's negative 3x. I'm not going to do anything else because these are not like terms, and I can't subtract them because they're not like terms. Okay, number 8. This one has a subtraction, but it also has a distribution. So what we're going to do to make this a little bit simpler, I guess, is we're going to say 2x, and then we're going to make this plus a negative 3. And that might help as you do the next step. So I'm going to say plus, and then negative 3 times x is negative 3x, and negative 3 times 2 is negative 6. Now look for your like terms. I've got 2 and negative 3, and that's negative x, and then minus 6. That's my final simplified answer. Okay, and then number 9, 5x times negative 2x is negative 10, because 5 times negative 2 is negative 10. X times x is x to the second. 5x times 4x is 20x to the second. So again, because I'm adding, and I have like terms, I can add those together. So negative 10 plus 20 is 10x squared. Okay, so today's lesson is on multiplying polynomials, and so we have some vocabulary words that we need to learn about. So the first one is term. We learned this before earlier this year. It's either a number or a variable, or a number and a variable multiplied together. So example, 6. That's a number. Negative 4a, that's a number and a variable multiplied together. 5 times xy to the second power, that's a number and a variable multiplied together. Same thing there, same thing there. Okay, so you can have lots of variables. You don't just have to have one. And each of those is one single term. So I've got examples of 5 different terms there. So here's the first term, the second term, the third term, the fourth term, and the fifth term. Okay, coefficient. Again, this review, it's the number part of a term. So it's the number that's being multiplied by the variable part. So in negative 4a, negative 4 is the coefficient. In 6x squared y to the third, 6 is the coefficient. We just had some review questions on that not too long ago. Okay, like terms, that's what we were just talking about in the warm-up. If you have the same variables and the same power, so the variable parts have to match exactly. What does exactly mean? It means no variation at all with the variables. So for example, 4a squared b and negative 8a squared b are like terms because the variable parts are exactly the same. Negative 1/2 x squared y and 15x squared y are like terms. So I could add or subtract them if they are like terms. Okay, so like on this one, if I had 4 minus 8 or 4 plus negative 8, it would be negative 4a squared b. Okay, the variable part doesn't change when you're adding or subtracting. On this one, if I was going to add, I would have 14.5 x squared y, because negative 1/2 plus 15. Okay, now in contrast, 8a to the third b squared and 8a squared b to the third are not like terms because they don't match. You see, we've got a to the third and then a to the second. They don't match. So they're not like terms. I cannot add or subtract. However, if I said multiply those two, then we can do that because we can multiply anything. Okay, next, these are new. A monomial. The prefix mono means one. So it's a single term. So anytime you have one term, that's a monomial. And so you'll recognize all of these that we did at the beginning, the 5 terms. Each of those is one monomial. So I've got 5 monomials listed here. Okay, the next one is a binomial. Okay, bi means two, like a bicycle has 2 wheels. Binomial is a sum, and that could mean or a difference because you, instead of subtracting, you can add the negative. So sum or difference of 2 monomials. So for example, 6, that's a monomial. X squared, that's a monomial. Since I'm adding them together, that's a binomial. Negative 5 minus 3ab. So I'm adding a negative there. So it's a sum of 2 monomials. There's a monomial. Monomial, I'm adding or subtracting, so this is a binomial. So if I said, what kind of expression is this, we would say that that's a binomial. Okay, the third one is trinomial. Now you might guess that that one means 3 terms. So a trinomial, like a tricycle, is a sum of 3 monomials. So for example, 2 plus x minus 3x squared. 1, 2, 3 terms. And then there's another example as well. If I had something like x plus x plus x, that's actually not a trinomial because I can add those together and I get 3x. So that's actually a monomial. So you have to kind of watch out for that. We'll have a few of those in there in the homework that may be tricky if you're not paying attention. Okay, the word polynomial, that is kind of a generic term, which means anything more than a monomial. So a binomial, a trinomial, anything more than that would be called a polynomial. So poly means many. And so examples, all of these that we just showed you, they're all polynomials. So when we talk about polynomials, we're just talking about all of that. Okay, the next thing is we're going to talk about the degree of a polynomial. So not kind of like how hot is it degrees, but the degree of it is the sum. So add up the exponents of a single term, and we want the largest in the polynomial. The coefficient does not matter when you're finding the degree. So if I ask you for the degree, what the coefficients are does not matter. So you've got a table on your paper, and so if we look at the first term, or the first expression, we've got 3 terms. There's 1 term, 2 terms, 3 terms. So you're going to look at each one of those, and we're going to add up the exponents in each of the terms. So this is 1. This one is a to the first, b to the first. So that's got 2. And this is b to the first. So the biggest one is going to be 2, so this is degree 2. Okay, let's go to the next one. 6, that's 1 term. That has degree 0 because there's no variable. X to the second, that has second power, 2 exponent, so that's going to be degree 2 also. So you see that degree 2, that can look a lot of different ways. It just has to do with the exponents. The third one, I've got 5x to the first, y to the second, so that's a degree 3 because 1 plus 2 is 3. 22x to the third, y to the fourth, z to the second, so 3 plus 4 is 7 plus 2 is 9. That's a 9th degree polynomial. And so that's actually got more degrees than anything else in here, even though it's only one term. So let's make sure we write this down. This is one term. So another way to say that, it's a monomial, and it has degree 9. Okay, so we're talking about this one. Okay, and then the last one is 2x, that's to the first power, because if there's no exponent, it means to the first power, so that's first degree. Okay, when we multiply or use polynomials, in order so that we all don't get confused, there's a standard way of writing them, so we call it the standard form of a polynomial. So a polynomial is written in standard form if the variables are arranged in alphabetical order, so A through Z, and the terms are arranged in descending order according to degrees. So for example, in 2 plus x minus 3x squared, I've got 1, 2, 3 terms. The only variable I have is x, so I don't have to worry about alphabetical order. The only thing I look at is I look at the degree of each term. This term has degree 2, this term has degree 1, this one has degree 0. So the way I'll write it in standard form is like that. Descending order, biggest to smallest. Now the reason that we write it like that is so that we can all do the same problem and not have, 6 different ways to write the same exact thing. So then we're all writing it the same way. So that's why it's called standard. It's just a standard way of writing it. So 5m to the second minus 4m to the fourth plus 7p to the second plus 6p to the fourth. First look at your letters. I've got m and I've got p. M comes first in the alphabet. So if I just look at the m's, the highest degree is to the 4th power. So that's going to come first in my standard form. Second will be that one. Then p comes next in the alphabet, so 4th power will come first, and then 2nd power. And so this is what we call standard form. So if you can simplify your expression, and I ask you to name it like a monomial, binomial, trinomial, you have to simplify it before you name it. So in order to simplify, you need to put it in standard form, combine any like terms, multiply or distribute anything that needs to be done. So we'll do a lot of practice with that. Okay, we're going to do in these first 6 examples, I want to have you pause the video and you're going to name either a monomial, binomial, or trinomial and tell me the degree of the polynomial. So have you pause and then you can come back and we'll turn this on and you can see if you got it right. Okay, number 1, this is a monomial, and it is degree 2. Number 2, this is a binomial. It's degree 2 also because this has a degree of 2, this has a degree 1. Since 2 is bigger than 1, it's a degree 2. Okay, the next one is a trinomial. Oops, I can spell. Trinomial, and it is degree 2 also. Because again, this is degree 1, this is degree 2, this is degree 0. Since 2 is bigger than 1 or 0, it's degree 2. All right, now with number 4, we do something a little bit different. Because it says multiply, I have to multiply first because I don't need like terms, so I have to take care of whatever needs to be taken care of. So 2 times 4 is 8, and then x to the third. So this is actually a monomial, and it is degree 3. Number 5, even though it's in parentheses, there's nothing to multiply. And since it says add, since they're not like terms, I can't add anything. So it is what it is. It is a binomial, and it is degree 6 because the 6th degree is bigger than the 2nd degree. Okay, and then the last one, there are no like terms for me to add or subtract. This one is degree 2, this is degree 1, and this is degree 0. So since 2 is the biggest, it's degree 2, and it is a trinomial. Okay, next. We're going to simplify by combining our like terms, and we're going to write in standard form. So remember, that's going to be alphabetical and then highest degree to lowest degree. So combining like terms. So remember we did this earlier this year. Look for like terms. So x squared, I've got 3 and I've got negative 1. So 3 minus 1 is 2, 2x squared. That takes care of those. Then I've got 4x. There's nothing else to go with that. So plus 4x and then plus 2. They're not like terms. I can't do anything else. We don't do anything with the exponents or anything like that. So then I'm going to say this is a trinomial. Oh, actually, we're not being asked if it's a trinomial. It's a trinomial. It's in standard form because it's going highest degree to lowest degree. Okay, number 8, look for like terms. So x squared, that's the highest degree in there. So that's going to come first. There's nothing else for it to go with. So 5x to the second power. The next one is x to the first power. So I've got negative 8 plus 10. That's 2x. And then minus 4. So this is a trinomial. It's degree 2. I'm not being asked to say that, so I won't write it down. But that will be my answer. It's in standard form. Okay, and then the last one in this section, x squared, x squared. So if I've got 3x squares and 5x squares, I've got 8x squared. I do not multiply, so I'm not adding up my exponents or anything like that. Remember, if you have a cookie and you have another cookie, you have 2 cookies. Okay, next is going to be x. So 2x minus 4x. And then plus 6. So this is a trinomial degree 2. That's in standard form. So when you're doing the problems that you're going to be doing, you need to write your answer in standard form. And that's so that we're all having the same answer written the same way, and that's just the way it's done. Okay, the next one is write each polynomial in standard form. So again, we're just looking to see if there's anything we can combine, we can put together, and then we're going to make sure we've got it in standard form. So I see no like terms here. So I'm going to take the highest degree and I'm going to write that first. And then the next one would be x to the first, and then the next one would be just 2. So pause the video right now, do 11 and 12, and then we'll start again and see if you did it right. Okay, number 11, 5x to the third is the highest degree, and then minus 2x squared, that's the next one, and then plus 3x, that's in standard form. Number 12, the highest, okay, so we've got 3 different variables. I've got x, y, and z. So x comes first in the alphabet. So this is going to come first. Next comes y. So minus 3y to the third. Then comes z. So since I have 2 z's, I've got 4z and I've got 2z to the second. This is a higher degree, so that one's going to come first. 2z to the second power, and then plus 4z. Okay, that's my standard form. Okay, I'm going to end this video and start another one. And so pause a second and we'll go on to the next section.